I know that a large part of the audience comes from traditional game development or XR development, which means you are very used to working with a game engine. So working on the web might be a bit counterintuitive, especially when it comes to things like Gaussian splats or like these sort of advanced rendering techniques. When we build on the web and use Gaussian splats, we can use something called Spark.js, which is a package that is maintained by World Labs. And it's an actively maintained open source project. And this is sort of like hands down the best way of rendering Gaussian splats. It is extremely high performance, especially the version 2.0, which came out last week in early preview. But by the time the hackathon starts, this will be out as a full release, basically. I'll get a little bit into the reasons why this is and why it is like so good. So the part on WebXR here is going to be a little bit more sort of like extensive. If you are familiar with anything web 3D, then you've heard of Three.js, which is another very popular library for JavaScript or TypeScript, I guess, that allows you to render 3D objects directly in the browser. It's basically a 3D render engine with a scene graph. And Spark.js integrates into that popular Three.js library. The really nice thing about web development, especially these days, and I cannot stress this enough, is that there is an enormous amount of training data in all of the large language models that you might use for coding, like Claude or the newer GPT 5.3, for example, or Gemini as well. Like they are extremely good at TypeScript. And if you provide them with context and documentation, they basically write very performant and nicely architected code for you, which counterintuitively, even if you don't come from web dev, makes this a extremely approachable way of working with world models. And then, yeah, Spark.js just sort of like underlines that even further. And I'll show a few things about that. So Spark.js and like WebXR, I should also talk about that because WebXR essentially allows your headset's browser to display 3D content. I don't know how many of you have tried this out before. For example, with like video players, but also other like 3D applications. They are essentially just websites. So that means you don't need to download anything. You just visit a website and I will show this later as well, and you click enter XR mode. Since it runs on the browser, that means it runs on almost any hardware. I've tried this with the Quest. We've tried the setup that we have here also on Pico headsets. The Spectacles, for example, I just gave it a try as well. That also supports WebXR. It's an open standard. I think that the only headset that has not fully integrated this yet is the Apple Vision Pro, but maybe in the future if we hope. So it's extremely easy to set up, and again, high performance. And I'll get into the Unity-like interactions as well, because out of the box, WebXR provides you with like hand tracking and controller tracking. But for those of you who've worked with the Meta XR sort of like SDK and Unity, you will also find familiar things that I'll get into now, which is sort of like the immersive web SDK, IWSDK, which again, you already see the pattern here is built on the Three.js library, and it's maintained by Meta. It's an open source project that you can just find on GitHub. And it is still, and I should really underline this, it is currently in development still. And there are active like pull requests and releases happening. So this isn't sort of like on the sidelines. This is like in active development and kept up to date with like the latest components. So what Immersive Web SDK essentially provides you with is these Unity-like components like XR interactions, think distance grab, physics, locomotion, like teleporting, smooth turn, smooth locomotion, snap turn. It has a really nice sort of like spatial UI for panels, like 3D panels that you can interact with your mouse cursor as well as with hand tracking and stuff like that. It has spatial anchors, it has physics, scene understanding, pass-through, basically the whole thing, but it's all working in your browser. It's really magical. Like when I first sort of discovered this, I was like, oh wow, okay, this is really cool. And then it also has an XR emulator that really, really speeds up the testing because you can just basically simulate your headset in the browser. This is something that I'm really keen on showing, by the way. Um, so, uh, as you might have already guessed, like Spark.js and IWSDK, in my opinion, this is like the by far best sort of word model Gaussian splat pipeline if you want to do anything XR related with these Gaussian splat word models. It's unfortunately not quite as straightforward as it would be in something like Unreal, for example, because the two libraries, they also fight a little bit with each other. So the project that we provide has basically solved all of that for you. So this is the World Labs WebXR kit that combines Spark.js and IWSDK together in like a really nice and performant way. And yeah, we've solved like basically all the technical complexity for you. And we also provide a couple of helpers, like a Gaussian splat spawner, for example, that just takes a link to your Gaussian splat file and then displays it in the world. And also splat animations, which is something that is sort of unique to working with Spark.js, with the web-based renderer, where you can have like these fly-in animations that run directly on the GPU at almost no performance overhead. All right. So now this is sort of like the overview, but I think it's better to just dive in and show you how this actually works in practice and what it looks like. In this specific example, I'm using Cursor. You can also use VS Code. You could use any other IDE that you have available. I'm currently running this on a Windows machine. Normally, I run on Mac, but since I'm showing the Unreal stuff, I wanted to also show that this also works in here. So this is just the GitHub repo that I cloned. I didn't do anything to it yet, and I'm going to walk you through the brief and like quite simple setup process. This is sort of like the folder structure. In public, you have files that will be exposed to the client. That means you have like the Sensei. This is the SPZ file, the splat. This is the compressed file type, if you remember. In source, we have our scripts basically and some UI, and then there's also a README, which we also have in the browser. That you can see sort of like on GitHub here. This is basically the README. But this is going to be important later when we talk about the AI integration, because this will allow your agent to basically help you write code with this project a lot easier. If we now select the index file, this is sort of like the standard. This is the entry point. We can see that we have a bunch of imports, and for some reason that it doesn't show that these haven't been sort of resolved yet. But before you can actually launch the project, you need to do a little bit of setup. Here you can see that it says it cannot find the module. This is because you first need to install all of them. For this, you need to download something called Node.js, and we have a separate workshop, by the way, on this as well. But it's very simple. You download Node.js either on Windows or on Mac or Linux, I guess. There's like a simple installer. You just run the setup, and that's it. And then in your IDE, you can open a terminal. And there are only two commands that you need to know for all of this. And this is like npm, which is Node Package Manager, and then install. And you just hit enter. And this will now download all of the modules that are required for this. And it doesn't take very long. That's why I'm also doing it live. It just take like 30 seconds or something like that. And then after this is done, you will see that all of these sort of references here are now resolved. You can look into the node modules and you can see, for example, Babylon.js. This is a pretty long list, actually. So I suppose this is slightly slower because I'm because I'm also live streaming. But I also have a version of the project that already has this done. Here, just use that for now. Okay, so this is just the same thing. It just has all of the dependencies already. The thing that we need to do now is essentially we need to now run the dev server, as it's called, npm run dev. And this will start the server for us. This is basically like booting up your game engine, and you can open this in a browser, or you can also just open it directly in Cursor, which is my preferred sort of method. Then you don't need to sort of like leave the IDE at all. So you can now see this is sort of like our viewport as it would be in Unity or in Unreal. But this is essentially just a browser, which is kind of nice. And here you can see this sort of Enter XR button. And we made like this little UI here. So I can also click Enter XR here. And this is sort of like where it gets really cool with IWSDK, because we now have basically a full simulator of an XR headset. In this case, it's a Quest 3. You can also change it to simulate something else. You can simulate button presses, like this is the joystick for moving around, moving like this. And you can also move that sort of manually around if you want to do that. This mode here is useful for sort of like very fine-tuned testing if you have like a very specific interaction that you want to test. But they provide a even nicer mode, which is if you click on this little play icon here. Now I'm basically controlling this with WASD, like you would do with a game, and then the mouse. And I can, for example, pick up this sphere here and move around within the world model, and everything like renders really nicely in the browser. And this splat is actually pretty heavy. I think this is about 800,000. This is about 800,000 splats. Yeah. So this is essentially how you would develop using this template. And I'm just gonna exit out of here. I'll show you a little bit of the code. I don't want this to be sort of like too code heavy or too in depth. I just want to show that it is pretty simple. We only have 4 scripts in here, and none of them are like more than 150 lines or so, and most of it is comments anyway. As I said earlier, you can really vibe code with this and just tell your agent, please add me a new sphere that I can grab or something like that. And it will sort of like understand the project structure because it's not very heavy. Read the README, which has links to the documentation, follow the documentation, and figure it out that way, especially with a model like Opus 4.6 from Claude, from Anthropic. This is like a really nice way of just sort of easily developing stuff using world models and Gaussian splats. I'm just going to like quickly show you what the structure of the index file is. So you basically set your settings here. You can set the session mode. This is all IWSDK, immersive VR. There's also a mixed reality version where the background is the pass-through from your camera. You can see I've set hand tracking to true here. Locomotion is true. This is the moving around. Grabbing, I've set physics to false. There's also like full physics, also replicated physics. And then scene understanding, which would be if you want to do some sort of like mixed reality experience. And I have an example of how you can sort of like combine the two later on. then we just set the world camera position, and you don't really need to worry about any of that, to be honest. And adding a Gaussian splat is simply adding an entity, adding the component, the Gaussian splat loader, which is the one that we sort of like provide. And that also gives you the ability to play this animation that I showed earlier, which is like if I exit to the browser again. So every time you enter XR, it does this sort of like transition effect, and you can also customize that fully, essentially. Yeah, exactly. So this is how you add a Gaussian splat, and then we have like an invisible floor. I think that all of the code is like it's very simple. It's very, I think, nicely structured, and you can sort of like fully let your agent, your coding assistant, loose on this. You don't need to know TypeScript to work with this project, like at all, basically, which is a nice experience. I really encourage you to try that out. Yeah, and that's it. Essentially, all of the technical complexity we've abstracted away for you, so you don't have to worry about it, and you can just basically vibe. So going back to the sort of presentation here for a second. Now that you've seen the project in action and what the simulator is for the headset and all that, I wanted to sort of leave you with some inspiration on what you can do with a project like this. If you want to sort of like build on that. So this is the Visulingo. Nigel showed this earlier as well, but this is sort of the WebXR version. So in Barcelona, my friend Marcus and I, we developed this in Unity and realized that this workflow didn't really suit us too well. So we moved it over to WebXR after that, which is also where this template comes from, and why the template works quite well. Because we sort of solved all these issues before. So what you're looking at here is essentially a language learning app, a web app. You can join this with your XR headset, click on a lesson, then you will be transported to a cafe or to a market that is a Gaussian splat, and then you sort of like can interact with some of the words in there and get a score for the vocabulary and pronunciation. And there's also a demo available here.